Within the SILS lifetime library, students found that the descriptive metadata attributes they used changed over time. A way was needed to track the changes in description. We can modify the rule for finding files with specific metadata attributes into a rule that lists all of the metadata attributes that are being used in a collection. The steps to do this will combine multiple rule segments previously examined. Combine the rule for listing extensions with the rule for finding metadata. Print out the number of files that have each metadata attribute. Apply the rule to either a single collection or the entire home collection. The rule shown here counts the number of metadata attributes that are used on files in the home collection and prints out the result. All sub-collections within the home collection are examined. The list metanum.metaname includes elements for each of the metadata attribute names. The value of metanum.metaname is set to the number of files that include the metadata attribute. The total number of attribute names is counted in metanum.total. When the metadata attribute names are printed, tab characters are inserted in the output string to handle attribute names that have variable length and produce a cleaner output. The rule defines a variable star call for the collection. It creates a query star queue which selects metadata attribute name for the given collection. For each result in this query, it extracts the metadata name, increases the total, checks where the metadata name already is found. If it has been found, it increases the count by 1. If it hasn't been found, it sets metanum.starMetaname to the metadata attribute name. It then loops over all the metadata attribute names that were found. If the metadata name is not total, it then prints out the metadata attribute name, checks the string length in order to pretty print the output, and then prints out the results for the total. The policy function contains is used to check whether the attribute name has already been included in the list. The input parameters are the name of the list and the name of the element that will be checked. The contains function returns true if the attribute name has been seen before and false if the name is new. The code is shown here. Note that the for each loop is used to loop over all of the list.*e elements, checking each one for whether *e is equal to the input variable *elem. This policy function could be improved as it looks through all of the elements in the list even after a successful match has been found. It is worthwhile to think about the types of metadata management that are needed for your research collaboration. There are many tasks that could be automated. Loading of metadata onto files in your collection, packaging of metadata for export, packaging of metadata to create an archival information package, verification of the presence of required metadata, verification of compliance of your metadata with the discipline standard reserve vocabulary. We will investigate the creation of rules to automate each of these tasks during the semester. Take 7 minutes to complete exercise number 48. Run the metadata analysis rule on your collection. A copy of test-listmetadata.r is available in the public folder Life Zone Home RW More Rules. Add metadata attributes and run the rule again to see the impact. Please load a paragraph describing your results into the Lifetime Library in the sub-collection class INLS 624 by the end of today's class. DataDirect Networks, DDN, is a commercial storage vendor. Their storage products are used by the major high-performance computing centers internationally. Storage vendors have realized that current file systems have difficulty in managing millions to hundreds of millions of files. As collection sizes grow, the storage systems have to evolve to support descriptive metadata and enforce management policies. Storage resources have to evolve into data management resources. This desire has become feasible with the emergence of multi-core CPUs. The disk controller now contains a multi-core CPU with 12 to 32 cores that can be used to run applications within the controller. The cores can be used to support processing of data within the storage system or can be used to run data management software within the storage controller. DDN has been exploring the technology needed to turn storage systems into data management systems. One approach has been to install the iRODS data grid as an application running inside the storage controller. This makes it possible to connect a new storage system directly to a data grid, enabling policy-based data management on the files stored on the device. By choosing an appropriate set of policies, the storage system can enforce compliance with NSF data management plans or institutional management plans. The Engineering and Physical Sciences Research Council, EPSRC, is the United Kingdom's main agency for funding research. The EPSRC has implemented data management policies similar to the NSF data management plans. A joint paper with Dave Fellinger of DDN describes the basic ideas behind policy-based data management. See Policy-Based Data Management, The Future of Reproducible Data-Driven Research, American Laboratory. The EPSRC data management requirements include publication of datasets with associated metadata, generation of a digital object identifier, preservation of the data for 10 years. All of these requirements can be managed using computer actionable rules. If the iRODS policies are enforced within a DDN storage controller, then compliance can be assured. The mechanisms provided by the iRODS data grid address each of the EPSRC requirements. The data grid associates metadata with each object. Data retention is managed via a periodic policy. Complex queries can be issued to the metadata catalog to test all edge cases. Policy enforcement points can automate application of the policies. Auditing reports can be generated, and a standard policy set can be reused for additional projects. Every storage vendor examines how to mitigate risk of data loss. Once storage management turns into data collection management, the types of risk become more varied. The types of integrity assessments then include not only bit integrity, but metadata integrity, collection integrity, and identification integrity. Examples include generation of required metadata. If metadata can be extracted from each file and deposition, then metadata integrity becomes possible. An example is metadata based on feature detection within the file. The metadata can then describe the file contents based on the features present within the file. Publication of collections. Policies can be created that register collections into external indexing systems, such as Data1, when files become public. Scalability. Every system has a maximum capacity, amount of storage space, number of files, number of users. One way to scale systems is to federate multiple independent data grids. Database stability. The information used to manage collections is stored in a database. This is a central location that holds all of the information associated with the data grid, including the naming, arrangement, access controls, and policies. Fortunately, database vendors have provided ways to ensure reliability of databases. Approaches include database streaming replication, database backups, distributed databases, and master-slave databases.